Good morning, everybody, and welcome to episode of Intro to Space. Firstly, I would like to apologize for the videos coming late. Something came up last week, and I wasn't able to do the videos. So in today's episode, I'm going to talk about medium Earth orbit satellites. So there are two space applications that are mainly used here. The predominant one is GNSS, so Global Navigation Satellite Systems. And the other one is weather observation, although very rarely used. That's usually used in the geostationary orbit. So I'll just focus on GNSS systems. So there are 6 actually satellite systems that do this job, each one provided by a different country or continent. So the first one everybody knows is GPS, the Global Positioning System, that is provided by the United States. The second one is Russia. Theirs is called GLONASS. Third one is Galileo, provided by Europe. Fourth one is provided by Japan, and this is called the Quasi-Zenith satellite system. Fifth one is China. This is called Beidou. I think that's how you pronounce it. And the last one is provided by India. Theirs is called Navik. So the reason why certain countries make their own is because they want to cover just their particular country or continent, should I say, in also working with the United States one. And also global navigation satellite systems are free. It is free to use. You do not pay a cent. Those countries and Europe, they're the ones who actually pay for it all. If you're wondering why Africa doesn't have its own, because it's expensive. It's about $750 million per year. Well, that's how much the US spent in 2005. So you can imagine it's costing more. And you have to replace them every 10 years or so. So on each satellite, there's 3 or 4 atomic clocks, each have providing their own time. I think it's up to the nanoseconds, so it's super accurate. And it also has to be configured due to gravity. It affects the time. So Einstein's relativity actually does exist. What happens is we have our own atomic clock here on Earth, and we have one on the satellite, and we configure the one on the satellite to the one on the Earth due to gravity's effects. So we use these systems actually, mainly GPS, since that's the global one that everybody uses, we can actually use it to measure the height of Everest. But we're using something called the Yakamatic GPS. So that's when you have a yak and you put like a very accurate GPS receiver on top of it, and you can actually get to the, I think, centimeter or millimeters accuracy of the height of Everest. So GPS receivers are very small devices, like I think about that, like 200-300 rand or so, depending on how powerful you want it. So it can cost a bit more, but they are really, really amazing. Almost all devices on Earth have it, so you can get your accuracy or anywhere you are, your location anywhere on the planet within about, depending on how accurate it is, it's between 3 to 10 meters. The US one, since we all use it, is about 5 to 10 meters of accuracy from about 20,000 kilometers, more or less 20,000 kilometers. That's the region that they are found in. Another thing on the GPS satellites the United States built, they have nuclear sensors on them. So if there's a nuclear blast or a nuclear explosion anywhere on the Earth, they are able to accurately determine where it's coming from, anywhere on the Earth. So that's another good thing. They can be used also, the dual use is both for commercial and military aspects. And in the next part, I'm going to talk about the effects, what happens if these satellites were to disappear. So how it affects our society in general.